So we're going to write a function that's going to model this process that we went through. So say that you start with just x for your number. The first thing we do to it is add 4. So that would model step 1. Then we take that result, the whole thing, and divide it by 2. We subtract 3 from that, and then we multiply our entire answer times 3. So those parentheses or brackets that we've got around there are super important because we have to multiply the previous result, everything we've done so far, by 3. Now, because that's a little bit messy, we're going to go ahead and simplify. So I'm going to multiply everything times 3 over 1, and then go ahead and get a common denominator. So I can multiply 9 by 2 over 2 and turn it into 18 over 2, and then I can actually combine it with my previous fraction. So I'll have 3x minus 6 all over 2 as my simplified model of that process. So let's say we test it. Before, when we plugged in 8, you got 9. So let's test 8 in this function that we wrote. Well, we end up with 18 over 2. That's 9. So it looks like our model is correct. All right, now I'm going to skip back to B. So this is kind of thinking about if my end result of this process is 15, what's my original number? Let's start by going up here and thinking, okay, the last thing I would have done is multiplied my previous result by 3, and I ended up with 15. So if I go backwards, 3 times what gets me 15? Well, it must have been 5. You can think about reversing the operation in that step and dividing by 3 instead. Now, just before that step, we would have had to subtracted 3 from something to get down to 5. Well, if you think about, again, going backwards, what minus 3 gets me 5 must have been 8. We essentially did an inverse operation and added instead of subtracted. Okay, so just before that, we divided something by 2 to get 8. Let's multiply by 2, so 16. And then if you go to our very original step, we added 4 to our original number to get to 16. So let's subtract 4, and our original starting number must have been 12. So the idea of two things being inverses are that they sort of undo each other. If I take one of them, like going forwards in that number process, then the other one, going backwards, undoes it and gets me back to my original number. So let's say f of x and g of x are inverse relations. That means that if I start with like f of 2, plug in 2 and I get 6. If I take 6 and I plug it into g, it gets me back to 2. So those two would be inverse relations. So basically they swap your input and your output. So if I have a function f with this set of coordinates down here, the inverse of that, g of x, would just have all those xy pairs swapped. So instead of 2 mapping to 3, like in my original f, 3 maps back to 2. Now my original f of x was a function, no input mapped to 2 outputs, but if you look at g of x, now 5's mapping to 3 and to negative 2, which means the inverse is not actually a function. So they're both relations, f's a function, g is not. Now if they were both functions, notation-wise, you would use f of x and then f, what looks like negative 1 power of x, to represent f and f inverse. So that's not a negative exponent, though, like you think of 2 to the negative first as being 1 over 2. It's different. It just represents function notation and says this is the inverse of function f. So just notation-wise. All right, let's take a look at a couple graphs. So maybe pause and see if you notice anything about these two lines. It's not super obvious, but if you think back to your geometry days, we talked about like reflections. If you take and look at the line y equals x, so like slope of 1, y-intercept of 0, these two lines are reflections of each other across the line y equals x. Anytime you have that being the case, that indicates that your two functions are inverses of each other. So say that I've got two relations here. They can be crazy looking. So say there's one, and here's my other one, and I'm trying to figure out if they're inverse relations. If you draw on the line y equals x and to think about folding them over that line and they match up, they're inverses. If they don't, then they can't be inverses. So say I've got like that line and then another relation. Those are not gonna fold up and match up with one another across y equals x, so they're not inverses.